Hey and welcome. Today I will show you how to solve one of the most asked problems in Leetcode called reverse a linked list. This question has been mostly asked by Amazon, but it also asked by other companies like Apple, Microsoft, Uber, Oracle, and a few others like so. We will use JavaScript and explore an iterative solution. In the next video that will come after this, I'll explain you a recursive way also. So make sure to stay tuned for that one by subscribing to the channel. So without further ado, let's dive in. Okay, let's go through the problem first. Given the head of a singly linked list, reverse the list and return the reversed list. Let's see some examples. First example, as you can see, we have numbers from 1 to 5 and each number is pointing to the next one, 1 to 2, 2 to 3 and so on until 5. But in below we can see the reversed result and now everything starts from 5 pointing to 4, 4 to 3 and it continues until 1. Second example, it is basically the same as before but with only two numbers, 1 and 2, and the reverse becomes 2 pointing to 1. Last one here, there is no nodes in this linked list. It is empty, so we should return an empty head of linked list. Before jumping into the solution, as you may know, there are two ways to iterate through a singly linked list, iterative or recursive. Since our solution is for iterative one, I need to explain you first how we can iterate through a singly linked list iteratively. There also will be another video for recursive solution. So basically for traversing through a linked list iteratively, let's say we have a linked list like so. The iteration process is a bit different with linked lists. We are not going to use a for loop like with the array case where we had an automatic index indicating where we are in the array, but we will have our own pointer in this case as the current value like there. Every node in linked list contains its data and it also points to another node until the very last node points to null. And basically that is how linked list data structure stored in a distributed manner in our computer memory, for example. Not as array that would take up a continuous space of memory. So in order to iterate through our linked list, we need to get a clue from one current node about the next node and follow that. So for example, at node 1, we know that its next value is 2. We know it because the pointer of node 1 says it to us. And based on that fact, we update our current pointer and move to the next node. This cycle happens for every node in the linked list until we reach to this step, until we have literally nothing that points to another thing. We have null. So whatever we do inside of this traversal flow that I showed you is up to us. We can calculate sum of values or log them or do whatever we want. The code for this is very simple. Honestly, just a pointer and a while loop like that. And as you can see, inside of that while loop, we just log the value of our current node and then moving on to the next iteration by replacing our current node with the next value that it points to. As simple as that, we traverse through our linked list iteratively. But now let's go back to the question. We have a linked list like so and we want it in reverse order. So how we can do that? One side note before we start, we will do the same few line traversal code but with a little bit of change. So basically we will have a previous variable initially as null, which will be in charge of storing a reference to the previous node in iteration. And then we'll also going to have a temporary variable to reference the next node. So what will be left in the middle? The current variable. Then our work will become as easy as changing the pointer of current node from next to previous. So after doing this, now it should make sense to you that why we had the reference to the next node before switching the pointer. We had it in order to not get lost in the linked list sequence because now we have a pointer that points to the next value of our current node. We have a way to track the next item in the sequence. At this step, what we need is a slight shift for all of our three variables here. Simply a shift forward in sequence. First, we will update our previous pointer, then our current pointer, and finally our next reference like so. Now as you can see, we are in a similar situation same as before here. So we are going to do the same step. First, switch the pointer from next to the previous, then shift our variables forward in the sequence like so. And this cycle is going to continue like that until we reach to our fifth node, the one before final check. We can clearly see that the value that node number 5 points to is null, which literally would act as a break case for us in order to exit or traverse. And if we do one last shift in here, our current pointer will be null and we have nothing that points to something else, which would mean that we are done with our traverse. Now look what we've got in here. Our previous pointer is at node 5 and it would act like an entry point to a reversed linked list. Finally, at this step, the previous variable would be a representative for the head node of a reversed linked list. And with that, we successfully did the job here. Now let's jump into the code to implement it. As you can see, Leetcode is showing us what the list node includes inside of it. It first includes a value of the node, and the next thing is the pointer that the node is pointing to. First, we will create our previous variable and give it a null value, because after reversing, our last node should point to null. So we will do something like let prev equal to null. Then the same basic current pointer we saw in the traversing code snippet. So let current is going to be our head. Next, we will have our while loop, but this while loop will continue working until we have a valid node. So we need to check for current variable to not to be falsy as long as we have something as current value. We will do while current and do something inside. Now it's time to keep a reference to the next node, because remember that we don't want to get lost inside of our linked list and lose track of pointer to the next node in the sequence. So we will do let next is equal to current.next. Then it's time to switch our current node's pointer from next to previous. We will do current.next equal to previous. Then it's time to update our pointer. First, we will update previous pointer, assign it to the current, previous equal to current, and our current value to next pointer that we stored in the beginning of our loop, current equal to next. Finally, at the end, if we reach into the end of our linked list, as I show you in the slides, our previous variable is going to be the most updated head value of the reversed linked list. So we can easily return it, like return previous. Now, if we run this, as you can see, test cases are passing, and if we submit, we are in a good shape. So let's do the time and the space complexity. For time complexity, we will have O of n, where n is the length of our linked list nodes, because of course we are traversing all of the nodes. For space complexity, we are not doing that much except creating some variables, so it will be O of 1 constant complexity. And with that, I can say that was it for this video, but don't forget that there will be another video for recursive version, but it is completely a different approach. So please like, comment and subscribe to the channel. Finally, hope you enjoyed this video and stay tuned for the next one.